carry that book, right? You need multiple people to carry that book. You no longer can, on the other hand, I give you a 10-page book, 10-page book, okay? One single person can easily look at that book. And I say, now look at how many times the word Janakiram occurred in that book. It's very easy for you to count. One person to count just go through this, and it takes maybe, maximum 15-20 minutes for some person to do it, and it's a doable job. But on the other hand, if I give you 10,000, 1 lakh pages book, then I say, now, like doing this, Ramakoti, writing, 1 crore times Rama, 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 Rama. It's no longer easy to do that. I remember my mother has done it long back, and she wanted me to accompany her along with others to actually when she wanted to give that. But it's a mammoth task. It is not an easy task for any one single person to be finishing it. Okay. Similarly, if I just give you, 1 lakh pages book, and now ask you to count the number of times this word Ram or Jankiram occurred in that book, then first thing is one person cannot carry the book. One person, beyond the capacity of one person to be able to carry the book. So you need multiple people to be doing this task. Okay, that is similar to by big data. Okay, suddenly what can be done by a single computing system need not be considered as big data. The minute it is beyond the capacity of a single system, and you need multiple number of computing systems to be able to handle, then we call that as big data. Right? What was big data previously need not be a big data now. For example, when we all started, even what is the operating system used to be? Operating system used to be in a 5/1/4 inch, floppy drive. I don't know how many of you would have seen such a floppy drive. It's 320 KB. The capacity of the floppy drive used to be 320 KB, kilobytes, and the whole operating system used to come in 320 KB. This is early 80s, 81, 82, in that time frame, maybe 83. MS-DOS. The operating system used to call Microsoft desktop MS-DOS. Okay. So if you look at the Windows 10 operating system, it actually will be few GB, right? What used to be very, that time that few MB is big data, now few terabytes of data is big data. Things are changing as we speak. Also, things are changing. So, one way to understand big data is what cannot be easily handled by a single node, and you need to ideally employ hundreds of nodes, computing nodes, to be able to tens, hundreds of nodes, maybe in some cases even thousands of nodes, to be able to handle data or process that data. That's what we call as big data. Okay, the term big data. Both big data and cloud are together in some sense. Cloud is probably more from the infrastructure as a service point of view. But if you look at data, we have huge amounts of data, and you want to actually process this data. That's where cloud comes into picture. The elastic part of the cloud comes into picture. Okay, we'll tie both these concepts, both cloud and big data, in this course. So this is not just a big data course. It is a big data course plus cloud course. Okay, so we'll see how both these things come together in this course, and how we will actually use cloud computing for doing big data analytics, how we want to actually do a lot of processing of the data, and what kind of algorithms we're going to use for processing data is what we mean by the big data analytics, what kind of algorithms that we're going to use. Okay. Before we get into the analytics part, what we're going to look at is first the big data processing part. Okay, what are the challenges of big data processing? Okay, if any questions, please interrupt me, because I'll be going little slow now. I won't be faster. but I want to use the blackboard and a whiteboard here. Okay, I'll probably do that as I'm doing. Okay. If you have any questions, please no, stop me and ask the questions. We can have some interactive session as well. We're just in the middle of the course, so before I again pick up speed and become a little faster, I thought that I will be little take little breather here and then try to get you on board on the kind of stuff that I'm doing. Okay, so ask questions if you have any questions, right? Yeah, so I will go with this example that I have about 1 lakh pages and how I would like to find the keywords in this 1 lakh pages. It's possible that I'm only in finding one word, but it still is not doable by a single machine. Okay. Now the question is, if I'm using multiple machines for doing this work, how do I? Now the last time we were asking this question, this is where we were last time. The way I wrote my Java program, the clients were programmed last time. Can I write the program in the same way? Okay. And what are the difficulties that I'll face if I start doing big data processing using Java the way traditionally I've been doing it? Okay. There are interesting answers that came in last time. We're going to go forward with that. Okay. First thing is, this is a very key thing. If you look at the way the whole distributed computing is moving, the whole distributed computing is trying to raise the abstractions higher and higher. And what people earlier have been doing, at the lower level, like the assembly programming, now people are moving into higher and higher, abstractions, and they don't want to program at the lower level anymore. Okay. There are a variety of frameworks that have come in now where people will hardly do any programming. All that they would like to do is just do a very high level framework and do a few little things, and the rest of the work should be done underneath by the frameworks. Okay. There are very good examples for this. In general, the whole distributed computing wants to move to that frameworks. Okay. People don't want to actually program at the low level. In fact, the client server stuff we did program at the very low level. In fact, we opened the sockets, we sent the messages have been received at the other end, the server is showing those messages. People would like to actually avoid writing programs at that level. It's very error prone. First thing is, it's very error prone. If you're writing your programs that way, you could make a lot of mistakes. And also debugging. If something is wrong, debugging the program is also extremely difficult. Okay. Just to make you understand why these abstractions are becoming very important, I will show you now one framework. Before I go on to Hadoop and then what is Hadoop and all that, I just want to also introduce to you a very coming up in the distributed systems where people are using that framework as well. The thread pool framework I couldn't cover. I just was about to cover, but then I think we somehow moved away from that. Okay, but this framework, which I'm trying to touch upon today, is also an important framework. I think you should make an attempt to study it yourself. Do a little bit more study in this direction because it's becoming one of the most important frameworks. Okay? Everybody is doing the web programming using what is called the Node.js, JavaScript. Okay, JavaScript is very popular, but then people have created people have created additional frameworks on top of that called the Node.js. Writing now, most of the web servers, majority of them seems to have been written in Node.js. Okay? This is a framework. It just makes developing your web servers extremely simple and easy. It's a high level framework. The abstraction is risen to such a level, everything of just making a web server is made quite simple. It's made quite easy, right? So let me show you how this whole Node.js thing works. Okay, I'll just share my desktop, and then after that, after doing this, we will get on to what is called the Hadoop, and then how Hadoop actually raises the abstractions distributed programming for big data. Okay, right. So let me try to see if this node is actually available here. I think it is available. Okay, so this is actually a framework, so you can actually see how the okay, now there may be a JS program. So there is a hello JS program. So this is the as you can see, this is written in you know uh, in JavaScript. This whole thing is written in JavaScript. Now, what the Node.js will require will actually will do is, as you can see here, okay, um, it's a very high level framework. I'm not. I hope you are able to see whatever I put here. Okay, I'll just try to open this in the this is a hello JS. As you can see, let this requires an HTTP becomes a module now, which can be now an instance of that can be created in the Node.js. So this first one actually creates a HTTP instance for you. Okay, it makes this listen on port uh, you know uh, 8080. As you can see here, HTTP. Then you got here you are creating an HTTP server and making the server on the port, and then a function that is given here will be the callback function. When somebody sends a response, this function will be executed, but in this particular case nothing is going to get executed. All that is you're going to now, this is basically the the request response. So when you actually this function handle request, okay, which is the we need a function which handles requests and sends a response. Now you can see all that it actually this HTTP. You can write more complicated stuff here. I'm not going to go into that. Okay, all that I'm going to show is now, if you just say that it works and this is the path or whatever it is, that's what this server will print when you try accessing this server. Okay, you can make it more complicated. You can make it listen to, and the responses can be more complicated and all that. We are not interested in looking at that. All that we are trying to see is now how a web service can be created, and request responses for the web service can be created using a very high level framework. We are no longer looking at any lower level, going into CGI bin script, writing the PHP, connecting that up with a push, and all that stuff. All that is eliminated now. This is a very high level framework. Okay. Um, Now see how this actually makes things very simple for you. Okay. Now you run this node. This becomes a node is a framework, Node.js framework. This allows the web servers to be run. Okay, right. Uh, I guess is node working? Node seems to be working. It should work. Uh, hello JS should work. I have yeah, maybe I should import some more statements as far as requires. This is saying that I need the module for compilation. So this is possibly, let me go to the other one where possibly I had actually created the uh, let me see if there is a I think there is, let me go to the other. Anyway, I'll show you the little more deeper aspects of it, because I'm just trying to get the, hope I have a script here which is okay. I think I thought I'd created an instance of this somewhere. Now I probably have to figure out where it is. I was showing you the Twitter example which we are seeing the other. Okay, this is a slightly more detailed example. Okay, so I will try to show this example for you, which was written on okay, so this will have the server. This is whole thing is developed in okay, in Node.js. So if you actually say now, this will basically, now you can see right, this server is running on this. So what you do is you write your server, and then and this server actually leads to this request here. All that you can do is now you can just go to wait Twitter play on this. Okay, sorry, this is actually the 10.6 32. Okay, this is supposed to be no, this is what it will give you. Okay, now this whole framework, this whole Twitter play is for example, when you go here, this whole thing is developed in what is called the Node.js framework. Okay, now this goes to Twitter, and then takes the your login ID and prompt, and goes into the goes into the into the actual Twitter play here. So I think we can just see the the stuff here. What's the okay? So the whole thing is actually written. No, this I guess I should kill this one. Close. Okay. So what I think I should have a much simpler example. I guess I had one simpler example. Let me see if the framework is possible. I think it should have one simple JS file which should be running. I think so. Of my fixing these things, where did I keep that one? I thought I'd kept it on this file. Okay. Um, this should go. I don't know what's the problem with this. I guess I need to import some statement here. I guess let me see. I think some time. I think I probably is missing something here in the I thought I'd kept a working example. This is one of the problems. I think I should have checked for the class something. Okay. Otherwise, I could be making a mistake. Real-time debugging, it sometimes has this problem. Okay. Let me try to fix it. I think I should have a JS file somewhere, either here or in the other place. Um, I'm going back to the server and checking where I kept this. Okay, a working example, very simple example where it just takes a hello thing and then works. I thought I had to. Let me just see if I'm making a mistake on this and see if I can, okay, let us just look at the server.js. It should give us some clue to if I'm actually, yeah, I think this is a server setup. As you can see, this whole program, for the Twitter play is actually written using this Node.js, okay, the JavaScript. Okay, as you can see, this also opens a backend MongoDB connection as the Twitter handles are coming in. As you can see, this whole, it goes to the, whatever the backend connections and um, all the stuff that you're seeing will be written in just this no 30-40 lines of code. That's what it will be requiring. Even going and then looking at the Twitter handles and then trying to log you in. All this is what it takes. Um, in terms of writing this entire code in the higher level framework is just there is some problem on this. It should not be just getting on to this status request. Okay, but anyway, this, since I've shown you this, I'll not fix this now. What now we were getting, what you would have got if you had just gone to this Microsoft site. Microsoft site will take you. This is hosted on the Azure website. So if you go there, whatever program that we have written there will work similar to this. It just takes the Twitter handle, goes there, logs you in. This is under development, so a lot of changes. I'm actually seeing synchronous asynchronous problems in this. So the idea is it comes here, then you can give, for example, the custom keywords, okay, and you can say this we are showing you last time, okay, Donald Trump or something, right? If you just give this just goes and then, sorry, this I think you should say Trump, right? Not so this is still under development. What you should realize is this requires some debugging, but this whole framework, okay, is written in Node.js, which is a higher level framework. Actually, next time when I actually do the next class, I'll probably fix this for you and show you a simple example. I thought I had a Hello.js, simple framework to just show you how the whole thing should be working. Okay, somewhere possibly that Node.js thing is giving an error when I actually compile try to run this JS with the Node.js, is giving an error there. I won't be able to fix the bug. Normally I should have checked it beforehand. That's okay. So I think that's possibly is the kind of frameworks that are becoming very popular. Okay, that means you no longer would like to write the web server the way you have previously developed a web server. Go and write a CGI bin script, and then put the all these scripts there, put it into www server, and then put a index HTML page, okay, and put a post. That's the traditional way of developing the web server. Okay, people don't want to do that anymore. What they would like, something like this Node.js framework, which will automatically create an instance of the HTTP server for you, and you put server should be responding to the requests and responses, and then the whole server will be developed using the Node.js framework. Okay, so that is the higher level frameworks that we are seeing becoming extremely popular while you are actually developing the distributed. This is something that's becoming very important in distributed computing. On the same lines, what you see now is what is becoming extremely popular as part of using the big data framework is this Hadoop framework. Okay, Hadoop MapReduce framework. again they're supposed to sort of reduce your programming effort and make you actually go and then create only two functions when you're dealing with big data. Okay. Now, how is this framework? This bigger framework will work. If a bigger framework works something like this. Okay. Now, getting back to the previous example of having a very large book and trying to do the you know, counting of words in the large book. This actually comes as a word count example. Okay. What you want to specify here is, now let us say I'm employing for counting the one word. Let us say I'm counting the word Janikram, how many times it occurs in this 1 lakh page book. Okay. Now all that I want to specify is, given each line, I would like each line becomes a tuple for me. Okay, each line in the page becomes a tuple for me. So what I'll now specify, how each tuple should be processed. When you read each tuple, how it will be processed. So all that I want to find out is how many times this word is occurring. That string, I would like to just find out how many. So that's basically called the map function. Okay, what does this map function take? Map function actually takes a key and a value pair. Okay, so how I'm going to specify now my higher level function for doing this job? I'll say that uh, um, I think that whatever occurred in that line, that will be the output from the map function. Okay, now that's not enough, because for this whole to work correctly, if each of these map functions is throwing up how many times it found, somebody has to now collate all the results of these smaller map functions and put it together as a final value. Okay, that is what we call as a reducer function. So what you have is a map function and a reduce function. Okay. Um, Now the map is supposed to be working on the map will have a input as a key value pair, and it will output a key value, another key value pair as an output. Now what the reducer does, it takes this key value pairs and does whatever collation it is supposed to do and give a final output value. Now what is the programmer is expected to write now? Programmer is expected to only give what is a map function does and what is a reduce function does. Okay. This is the only programming that he has programming. And what will he give? He will give a map function, reduce function, and the large data file on which these maps and reduces should work. Okay. Now it's up to the system to divide this 10,000 pages or 1 lakh pages among 100 people, 200 people, 500 people. They are asked to do this individual task. So each person will execute a map job, and whatever he is getting, he'll output that. So there will be another person called the reducer who actually takes the output of all these map jobs, map people, and then puts everything together. For example, if 10 fellows have said Ram occurred 20 times, then I will say now Ram occurred, I'll just put all of them together and say finally Ram occurred some 100 times. Okay. So the whole distributed program will be now equivalent to just writing three simple functions, a map function and a reduce function, and specifying the data on which these functions should be operating. And the rest of the things should all be done by the system. For example, if you are using 100 nodes, the system should automatically create 100 processes or whatever underneath. The whole Java program that we have been writing will all be done automatically by somebody for you. He will open up which are the nodes that should be participating in this job, then what job should be given, what data should be given to it. The whole job is to be done automatically by somebody else for you. You won't really want to concern yourself. Okay. With writing the low level socket programming that we did in the first place with Java programs. Okay, that's the power. Now, once you understand MapReduce, we are no longer going to write these Java programs at the low level. All that we are going to now do is write these programs at a very high level, where you specify a mapper function, you specify a reducer function, and you give the data on which this is supposed to be operating, in a particular way, and then the whole thing is done for you. So you will say employ as many nodes as you want. For example, this program can be run on 100 nodes, 1000 nodes. You don't make any changes. The program automatically, the data is automatically split, stored in this different nodes. The map and the reduce functions will automatically get triggered by the system at appropriate times, and then you will get the final output value. This is what we mean by distributed frameworks. You no longer would like to program at the low level. As we said last time, if you're programming this at a very low level, we need to have 100 IP addresses. Okay. Now tomorrow I want to run it on 1000 nodes, the whole program will change. Okay. Now I have to recode everything for making this program run on 1000 nodes. My data now becomes 3 times my current data, then the whole program has to be changed. The way the lower level program, hardwired connections, everything needs to be changed. That is the power of abstraction. Okay. And that's what we would like to move on to in distributed computing. We no longer would like to program at the low level, and we expect there are tools, compilers, and automatic frameworks that are available which can do that job for us. Okay. So let us go a little deeper. Okay, up to this point, is that clear now? That Node.js thing I will just show you. For example, next class I'll show you that Node.js. If I run that Node.js, it becomes a framework and the web server will be up. All that I need to do is, if I just access it now, that web server is on for me, and then it will give a response. That's a high level framework. In a similar way, what we would like to do is, when we are doing a big data programming, we no longer would like to work with low level socket programming, where we open the sockets, send the messages. Okay, we would, and also that doesn't scale, and also it creates the problems of making sure that as the data changes, how I'm going to use that. So that also becomes a problem. I can't keep on changing my programs. If I'm working on 5 nodes, I have one program. If it works on another 20 nodes I add to my program, then I have to completely rewrite my program. This is stupid. It doesn't really make sense for me. Okay, that's the time these frameworks become extremely important. Okay, is that simple idea clear, or you have any questions? Okay, this is what we mean by, this is what we are going to do in the next few classes. Is we will show you how to do MapReduce programming. Okay, we will make you understand MapReduce programming. We take some example data sets and we write MapReduce programs, and we'll run these MapReduce programs. And if you understand now MapReduce programming, it should be a good it will be good for you to get employed in all these big data analytics companies, because many of them, understanding Hadoop and MapReduce programming is an essential skill now. Okay, they expect you to understand how Hadoop and MapReduce work. There are a lot of distributed programs are now written in Hadoop and MapReduce. Okay, so that's what we are going to concentrate on. Is the basic idea very clear for you now? This is what we're going to concentrate from now on how we will basically do the MapReduce programming. Okay, is that clear? One part of the abstraction is the writing abstraction, map function and the reduce function. Okay, now the second part of the abstraction is the file system, how the data is stored. Okay, this is essential now. In fact, what we should realize is, it is the data first and the program later, as far as the whole idea of Hadoop and MapReduce is concerned. Hadoop comes first, the file system comes first, and the MapReduce comes later. Okay, why is this so? It is because of the following reason. Now, first thing is, if you want to process this 1 lakh pages, what is the first thing that you will do? You will first distribute this to 100 people or 200 people, whatever number of people you have. And what is the way you're going to distribute? we are going to tell each one will get a 200 page or 500 page or whatever chunk that you decide. You will put that much chunk with each of the persons to start with. And ideally, what will you start doing now? Those are the people who will be counting things for you. Okay, those are the people on whom the map job and the reduce job should be working, so that the final output can be produced. Okay, so the first part of distribution of your data is called the Hadoop file system. Okay, using Hadoop as a file system, first what you can do is you can create distributed files. You can store your data in a distributed fashion. You can split your data, store this data on multiple nodes of the network. Okay, that is basically called the Hadoop file system, or this is also known as HDFS. For simplicity's sake, it is called HDFS, Hadoop file system. Okay, distributed file system. That's what HDFS stands for. Okay. Before Hadoop was there, Google was the first to invent this whole process of MapReduce, because Google was doing this job of getting all the web pages. Okay, all the web pages. That will be few million at that time. Now it's few billion. Okay, few billion pages. The crawler goes and gets few billion pages, and then indexes these pages. For indexing, they are finding the keywords in all these pages. Using the keywords, they're indexing these pages. Okay, that's where this MapReduce plus Google file system. It used to be not Hadoop, but then it used to be called Google file system, GFS. GFS was the first one which introduced this. Google is the first one which introduced MapReduce in their large data centers. How Google was doing this? They're buying the servers, hundreds of servers, thousands of servers, keeping them in their data center, and day in and day out they are doing this MapReduce programming, because they're crawling all these web pages, keeping them in their data centers, because one node can no longer store this large data. So they're actually distributing this data using this file system called the Google file system, and then on top of it they are doing the MapReduce programming. Okay, for doing the big data now, and that open source, since Google didn't want to open source its Google file system, Yahoo actually spawned off a group for Hadoop development in the open source, and that became an open source distribution called the Hadoop file system. Okay, there are slight variations between Google file system and Hadoop file system. Hadoop file system being open became extremely popular, and you actually do the MapReduce programming on the Hadoop file system. Okay, this is the genesis for Hadoop file system, HDFS, and MapReduce programming. And using this, we expect to process large amounts of data. This is what we call as a big data processor. So Hadoop and MapReduce framework is meant for big data. What we are going to do in the next few classes. Okay, first we'll look at what is a Hadoop file system. Okay, how the Hadoop file system that's the first step. First we should know how the files will get distributed. Okay, is anybody familiar with any other file system, distributed file system, who is listening to this talk? Is anybody else familiar with a distributed file system which they are using in their labs? There's very one popular file system, distributed file system, which most of the labs use. Can you name that file system? File sharing system. Can anybody name that file sharing system? Anybody listening this lecture can tell me any other distributed file system they're familiar with? One other file system, distributed file system, before we get on to Hadoop and look at what Hadoop is about. Can anybody tell me any other file systems they're familiar with, distributed file system? I'm looking at the chat, see if anybody can answer this question. Okay. Nobody's answering my question. See, how are your lab labs having the machines? Anybody is having multiple machines in their labs? Obviously, the answer is yes, right? We have Windows, or Windows machines, Linux machines, all these are there, right? How does your students share their files? Do you provide a network-wide file system for them, or you don't provide any file system whereby the files of the students can be shared? Is it LAN? No, that's in the LAN. What kind of file systems do you provide? Distributed file systems. Vijayanagaram campus says yes, but then what is the distributed file system that you're using? Have you heard the term NFS, Network File System? Is anybody familiar with network file system? Whoever is listening to me, they say they're not using any Vijayanagaram campus. Okay. Has anybody using what is called NFS, Network File System? No. Vijayanagaram campus says NFS, heard the name. Okay. But they are not. Okay. I think you should actually try to install NFS in all your but not familiar. But what about others? If you have 20, 30 machines, don't make them standalone machines where the files created on one machine will not be visible at the other machine, right? You should make what is called network file system. There will be a server and the files will be available on all the clients of the server. Okay, right? So that is basically called network file system. Okay. We also have in our IIT Madras campus what is called a peer-to-peer file sharing system on the campus called the DC++. Okay, this is also very useful file sharing system where each student gives some amount of space on the LAN for others to share, and that's how they all share together. For example, few terabytes of data storage is available on our local area network where students all share common files. They don't download every time somebody wants. They don't download afresh from the internet. What they do is they actually share whatever is downloaded. Okay, somebody is saying hello. Karimullah Shah, why are you saying hello? You have a question? Jntuk U4, do you have a question? They're just saying hello. I don't know why they're saying just hello. Okay. AV is thing they're saying. Okay. Audio video is probably is breaking for them. Okay. Yeah, that's probably. Please check with. I think some Karthik was I think online with the whole thing. I think please check with the AV guys. I think. Yeah. Okay. So the DC++ is also an interesting system. What people do is, for example, there were thousands of thousands of is Ramakrishna also on the from here? Yeah, he says we are getting good streaming. Okay, see, yeah, so I think Ramakrishna is online, so you should be able to check with him. Okay, uh, see this DC++. This is what I would like to tell you also. You should experiment with lots of things. This DC++ is a very nice file sharing system. What for example, you have 100 students, 200 students, and all of them have machines in their hostels or something. One easy way to share these things is there will be a hub, there will be a metadata server where all the file details, shared files can be there. Each individual node can give some amount of storage. For example, it could be uh, you know couple of MB or 10 MB, 20 MB, whatever it is. Now the distributed storage will have 10 MB into 100 nodes. Okay, and now whatever is downloaded, they all will be able to share instead of everybody downloading. So this is basically called the DC++. Please look at this DC++ as a take-home assignment. I suggest that you look at DC++. That is one file sharing system. Also look at network files, NFS. Okay, see if I would like to see if any of you can install NFS on your local area network and make the files for in a network fashion, your files in a network fashion. Okay, that's important to understand. But I wanted to go in little more detail and show you how NFS design is different from Hadoop file system. But we'll not do that. We'll straight jump into the Hadoop file system. Look at how Hadoop file system can be used for big data processing. Okay, how big data processing can be done using the Hadoop file system. Okay, so the rest of the lectures, I'll stop here and come back on. Unless you have questions. Okay, I'll now outline how I'm going to do the rest of the lectures for a few weeks from now. Okay, what I'm going to do is next class I will show you how to look at Hadoop files, how large files can be stored using the Hadoop file system. Okay, then I will actually show you, for example, one of the things that you can see is my laptop has this Hadoop downloaded on a single node. I think I have this Hadoop 2.5.2 downloaded here. Okay, all the examples, everything is available here. Okay, now what I'll show you is how this file system, this can be made a single on your laptop. Also you can install a Hadoop and make it as a single node system and run all the code that I'm single node case. Okay, you can also run it on multiple nodes. Okay, I'll show you how this file system, Hadoop file system, stores the files. Okay, what is the architecture of the Hadoop file system and how we are going to store the files in Hadoop file system. Then we'll look at some common examples. Okay, MapReduce. Then we'll understand what is MapReduce programming, and then we will actually see. And then I'll also show you a distributed version of the Hadoop. I will run which platforms support socket programs. What is the question? Which platform support socket programs means what? Can you elaborate on the question? There's a question coming in here. Next 5-10 minutes I'll spend on questions. Okay. Which platform supports socket? I think it is being asked. Who is asking this question? I think this is. Can you elaborate which platform support means? If you're using Windows, you can do socket programs using WinSock. If you're using Linux, I've shown you how to actually do the socket programming on Java using Java sockets. Okay, Unix platform using the C programs. With Linux, you can do the socket programs using the socket libraries, appropriate socket libraries. Does that answer your question? I don't know why you're asking that question. Which platform supports socket programs? That's a question. Is the question answered? Not answered. All platforms support socket programs. For example, if you take Windows, you can use WinSocket program. Sir, except Linux, where can we use them? That's not correct, because even Windows also supports. You can use Win. Okay, socket programming can be done on any operating system because that's the primary way you connect up machines and you program in a distributed fashion. So underneath everything becomes a socket. Okay, whether it is Unix or whether it is Linux or whether it is Mac or whether it is Windows, you do socket programming. Okay, but only thing is, if you are having Java, it becomes Java sockets. So on Windows, have a Java virtual machine. On Linux, you have a Java virtual machine. Both these programs can talk to each other using the Java sockets. Okay, is that clear now? Socket programs is a basic under lowest level. We will use sockets to do distributed programming. Okay, right? That's what we've shown you. That's where we gave you the understanding how to write distributed programs using Java packets. And that Java program, the client of the Java program can be running on a Windows machine. The server could be running a Linux machine. Okay, we can do that. So once you have the Java, it can be portable. It can run on any machine. Okay, right. Any other question you have? Is there any relation between number of live connections? What do you mean by that? Is there any relation? A number of ports? No, no, no. There is actually, there will be only one port. I think your understanding of ports is not correct. Okay, there is only one port. It will listen only on a port. Okay, as we saw in the previous case, when I wrote my server program, it listens on only one port. Everybody sends message to that port. If there are more people, for example, a client calls on the port, we are starting a separate thread for processing that request. Then as many clients that are actually calling me, that many live connections will be there in my server. Okay, right? So there is no relation between number of ports. There is only one port which the server can listen to. Is that clear or not clear? I'm surprised at this question because you also had written the program, the server programs, I think, and you also shared these programs. If there is a two-way communication, even if you have a two-way communication, because all that you're going to do is, for example, even if you have a two-way communication, what happens is the server, listens to the port. And then this is like the handle, the handle goes to the actual thread that is handling. So the port is only one there. The server port on which the server is listening is only one. Okay, but then there is a dedicated connection that gets established with the thread and the client. Okay, this is actually called this is a new term for this. It's actually called the conversational continuity. Okay, it is implemented in a slightly different way. Okay, but it has nothing to do with port. You don't require a port. Okay, we used 8080 as an IO port. No. I think that's not correct. Let me show you the program. I think just to give you a deeper understanding of this, I think you started understanding now. Okay, you're asking the questions. For example, I think we were actually doing this. If you look at these server programs that we had written, I think I'm actually not sharing my desktop. I think is my desktop shared now? Not shared. I'll just share the desktop. Okay. Now you look at this. Okay, now look at this program. I think there is a server program somewhere. I think, see, one of the problems for me now is as I'm being old, I think I'm actually forgetting where I had kept my programs. Okay, I think there is a server program. Yes. Okay. Now, if you start this new server program here, this will be listening on a particular port. Okay. Sorry, this is I think the we need to do the Java C on this. Then you can, I think, I don't know whether this is the correct version that I'm having here. I have several versions of this, but then I'll still run it. Okay. So this you can see if from the client side, when you connect to this, it will say where it is connected to, and then it will tell you what the, are you able to see this? I hope yes. Okay, see the two things. I'll keep side by side for you to be able to see them. Okay. Um, this is where the server is working. I'm trying to overlay one on top of the other so that you can see this. Not the one which I should get. Close. Okay, let me see if I can get a new window. So new window should come here. Okay, so this is where the server is. Okay, now let me go to the client. I think this I kept it here, so I remember that. There's a new client. Okay, now you see entered client. Okay, I guess the no, the these things are not synchronized now. I have to synchronize them. I think I would have changed the problem is I have to Emacs this is okay. This I don't need to change. Where I need to change is I need to change the client side. I would have actually disturbed the okay. I think I need to change the new client.java because I would not have been using. I think I changed here, so it should become the 10.6.84. Okay, 10.6.9.81. Okay. Now if I just do the this will be clear for you now. I'm able to do this. So now run this. You can see here. Now the once I've actually got this, if by running this you will figure out what's happening. Enter. This is actually taken this 10.6.9. 253. Okay. This is the the socket, the IS socket. That's a client socket that it has got now. You can see port number is 47926. I actually the port on which the client is listening to. Okay, server is listening to only one, but then when the client is a corresponding socket it is using. If you look at the connection there, the client socket is a separate socket open from the server side to the okay, and that is this socket, this address. Okay, whereas the server will have the 10.6.9.81 port number 8027. Client side is 10.6.9.253 479226. This is my local client here, right? So if you actually now I'm not actually writing. Okay, so this client says now done. Okay, input stream open. It read from this socket ID and then written the whole thing here. Okay, now if no I use a different different client, then this will be completely different. Okay, I can use another machine and then come here, then it's going to be a different one. The port, each time the port can also be different. For example, it need not be the same port. Okay, it's giving here as a same port, it's the same one again open, but if you're using from a different machine, it would have got a different port number. Just some port number which the client is using. Okay, this should make it clear for you. Okay, right, this is how this whole thing will work. The port on which the server is listening, okay, is that clear? With that example it should be clear. There's one server, one port, client, one port. So different clients will have their own IP address and the port number. Okay, is that clear for Vijayanagaram and JNTU? Is that port communication part clear, or I should no? do something more on this. If you have any question, then I can further go on that. Okay, is that clear? Okay, it's clear. Then we don't, if you have any question, that's how it works. As you can see, that port address of the client is also coming there when it is opening. Okay, the connection. Okay, so client will have, every program will have a port address to which you can start sending and receiving from that. So the client will be listening on one port, so you can use that port to send it. Okay, and if the server, you want to send a message to the server, you send to the server on that port. This is like, your cell phone number. Everybody will have a cell phone. Okay, now if I want to call you up, I will call you on your, that's a port number, I will call you on your cell number. Okay, so port number is like that. Okay, is that clear? Okay, so I think yeah. Okay, yeah, so that's the way it works. Fine, so I just stop this desktop sharing, and then I'll come back next class. So, but then the biggest problem with these ports is that opening these ports and then, making them communicate will be very cumbersome if you're using multiple machines, okay, at the same time. Is that clear? Okay, so I think then we'll come back next class and then look at